So in vapor phase, we can also produce our alkenes from alcohols in vapor phase. And how do we do it? If you get the vapor alcohol and you pass it over heated aluminum oxide, okay, and this one is going to act as a catalyst, then you form an alkene, okay, and this one doesn't have a mechanism. That's good news for you. So obviously the alcohol is going to undergo elimination. Why elimination? You're going to remove the OH, okay, and you form unsaturated compound, and in the process you lose a water molecule. Now elimination reactions, those are reactions that occur, that proceed with loss of either atoms or elements, with loss of elements. Initially you begin with an alcohol, but you lose the hydrogen ion, sorry, you lose a hydrogen atom together with the OH, you form water, and you form unsaturated alkene. So that one becomes an elimination reaction. Is that okay? So if such happens, if you find that in a question, in a paper, then you should be able to attack. So you just put here your cotton wool with soaked alcohol, and then you do the heating so that it evaporates and finds heated aluminum oxide. Okay? And in the process, when it finds this, then it will be oxidized. Okay? It will be reduced to form the alkene, and the alkene is passed. Now if you want to confirm that alkene has been formed, then you can use potassium, oh my god, potassium permanganate. Okay, and you know the effect of alkenes and alkynes on potassium permanganate. It will be decolorized. The purple solution of potassium permanganate, it will turn colorless, and so you confirm that seriously you have formed some alkene. Okay, yeah, this is just simple. So the second reaction, we can form alkenes from dehydrohalogenation of Vic dihalides, vicinal dihalides. Now, a Vic dihalide, I don't know why I didn't. Okay, where should I write, here or down? I need where to write. Okay, okay, it's okay. Let me write here, I won't forget. Now, a Vic dihalide, we have two types of dihalides. We have this one where the halogens are on the adjacent carbon atoms. Okay, then sorry, the rest are hydrogens. Now we call this one a Vic or a vicinal dihalide. Now vicinal means neighbor, neighboring. So in this case the two are neighbors, okay, because they are on adjacent carbon atoms. But also the other one, it is a gem, and in a gem dihalides, the halogen atoms, okay, they are on the same carbon atoms, okay, the same. So if the two halides are on the same carbon atom, then that one is a gem. But when they are on the adjacent, then that is a Vic or a vicinal dihalide. So we can prepare alkenes from these Vic dihalides or from dihalides. And how do we do it? It is an elimination reaction which involves removal of both hydrogen, that's why it is dihydro, and you also remove a halogen, that is why it is called halogenation. Dihydro, removal of hydrogen; halogenation, removal of halogen. We could not name it diharo, no, just dihydrohalogenation. It is the same thing. Okay, from a molecule to form an unsaturated organic compound. So that's why it is an elimination. You should remember types of organic reactions. where you have elimination reactions. Okay, let me just give you a brief reminder. Then you have addition reactions. Okay, and then you have substitution reactions. Now those are the those are the types of organic reactions. Okay, all organic reactions undergo this either elimination or addition or substitution. Okay, so in elimination you remove a molecule and you lose some atoms, and for instance you form unsaturated. From saturated you form unsaturated. Then with addition, for it just adds itself. A reacting molecule, a reacting species just adds itself across a double bond to form a saturated compound. Then with substitution, here you replace. Okay, you replace, like you have, let's say, carbon, you have atom X, and when you react this atom X maybe with atom Y replaces X, so that one becomes a substitution reaction. So this is an elimination reaction where the hydrogen and the halogen are removed. Okay, so a weak dihalide, it is that compound with two halogen atoms, but the two are positioned at adjacent carbon atoms. Whereas a gem, it is that dihalogen compound where the two halogens are positioned on the same carbon atom. So this is it. The your dihalide, if you burn it, if you heat it in zinc, okay, then the zinc is going to take away these halogens, okay, to form zinc chloride, and the result is an unsaturated compound, or an alkene is going to be formed. Mark this. We also use dihydrides to synthesize alkynes, and we shall reach there. However, the conditions are different. Okay? Mark the conditions. We can also use partial reduction of alkynes to synthesize alkenes. And how do we do it? Let me first clean the board, since it's the teacher to clean the board. Students don't want. So when we partially reduce alkenes, alkynes have a triple bond. But we can partially replace that triple bond with hydrogen, or with hydrogen atoms, two of them, to form a double bond. Okay? And so you have, maybe you are interested in an alkene. Okay? But you are producing it from an alkyne. You don't want an alkyne, but you want an alkene. So it's up to you. So when these alkynes are reacted with hydrogen in equimolar, mark this word, okay, in equimolar ratio, in presence of a heated catalyst. Now which catalyst? You remember this reaction, nickel at 150 degrees Celsius. Now if you decide to use nickel, okay, nickel, then it must be heated to this temperature, okay, 150 degrees Celsius. Then, but it must be in equal concentration. It must be limited, because if hydrogen is in excess, then all the double bonds, all the bonds, they are going to be replaced, and you end up forming a saturated alkane. So you try to limit the concentration of hydrogen as a gas, okay, so that the compound that is formed is an alkene, not alkane. Okay, so whereas when you use platinum or palladium, now these ones, they can be used at room temperature, okay, but still you limit the concentration of hydrogen. So that is your equation. You have your alkyne, okay, and the alkyne is reacted with nickel at 150 degrees Celsius. Then you form an alkene. It is partial reduction. However, in synthesis, please don't write for me this, because it is hard to control the concentration of hydrogen, and also it is hard to control that if this one is placed in one molecule, this molecule should first go aside, then let another molecule also come. It is the same reaction vessel. So this reaction is not efficient as far as synthesis is concerned. So if I'm the boss and you are the industrial chemist, and I tell you to synthesize an alkene from alkynes, and I see you using this, automatically I fire you. I fire you because you're going to produce a mixture of alkenes and alkenes. And remember, this is economy. The economy is too hard. But for you are wasting. Now, what are you going to use the alkene for? The alkene for. So to avoid that, then there is a good method of preparing. Okay? So the above method is not an efficient method of preparing alkenes. So as a result, then this guy, this great guy, he came up with his own method of preparing alkenes from partial reduction of alkynes. Okay? And what did he do? He used poisoned palladium at room temperature. So he got this palladium and poisoned it. Okay? And he came up with his catalyst, and he named it Rinder's catalyst. Okay? And how did he poison it? If you get this palladium, okay, and you add there calcium carbonate plus lead acetate, okay, then you add there quinoline. This one is it an organic solvent? I think you add there quinoline, then you produce this Rinder's catalyst. However, when you are writing your synthesis, you don't need to write all this. Just write for me. Maybe you want to produce, maybe which one can I say? Okay, I'll give you some work and you synthesize, or we synthesize it together. Okay? You write Rinder's catalyst. Just write the word, not this. So for instance, let's synthesize this. Let us effect this. Let me erase everything. So let us synthesize this. Let's say we are effecting this, okay? CH2, okay? CH2, OH. We are preparing this, and we are forming. Now this is science. I want you to form this, yes. CH, CH2, then CH2, OH. Can you effect this? Can you manage that? So I have, now I'm the boss. Okay? I'm your boss. We have ethanol. Enough of it, even excess of it. But now we want to carry out a given reaction, and the reaction requires us to use propanol. Okay? So you are the industrial chemist around, available. How are you going to effect that? So, it is simple. Let me do it. The first step you're going to do, Okay, if you are done, if you are trying, it is good. I give you some time. Okay, let me give you roughly 1 minute. Try it out. It is just 5 5. It clocks 5 7. I'll do it. Please try it out. Try. Hurry up, hurry up, hurry up, hurry up. How far have you reached? We are synthesizing. We are synthesizing. I hope I'm not going to fire all of you. Now, in synthesis, the shorter the steps, the efficient the method is. Actually, the one who uses the shortest method will give you promotion. We promote you for another level. Because economy, we are going to see. So anyway, it's time now. Let me do it. Now, what do you do? It's okay. Let me first use a red pen. So we are going to convert this, okay, to ethene, CH2. You should be thinking about the conditions and the reagents, okay. Now from ethene, we add there. Now we haven't studied the reactions of alkenes. So we add there, we form this Cl, CH2, Cl, sorry, CH2, Cl, Cl, it's okay. Now from this, then we form an alkyne, CH. Now somebody should ask, why should we form an alkyne? Because initially, you see, you have 2 carbon atoms, but you want something of 3 carbon atoms. So how are we going to increase the carbon chain? Okay, so that's why I'm doing all this. I'm aiming at increasing the carbon chain, and then after I reduce to the alcohol. So you form your alkyne, which is ethane, CH, and then from this I can form this CH3, CH. Sorry, there is no CH. I was almost erasing everything. It would be trouble. So this is CH. What's wrong with CH? Oh God. CH, and then from this I reduce. Good. I reduce to CH, 3, and then CH, then a double bond, and finally CH2. Now this is where our Linder's catalyst is going to be used. If you use hydrogen, then I'll cross you. You form a mixture, and our interest is not an alkane, but we're interested in this. But the Linder's catalyst, even if hydrogen is in excess, like how, okay, you always form an alkene. Then finally from this we can form this. Now the reason why I didn't write the conditions, I was intending it. I intended it. I want to see. Yes, you might not write them here, but think about them. Can you can you effect that equation, that synthesis, by writing the conditions there? Yes, anyway, however, there are some things you haven't studied, like this one, like this. So that is organic chemistry. Let me write for you the conditions. And whatever you haven't studied, we shall study it. Now this one you have studied, and I'm assuming you all passed. So here we can use Kong, sulfuric acid, sulfuric acid, at 180. Don't write a range. Don't write a range. Okay? You are not instructing me, but you are doing. So just write 180 degrees Celsius. Okay? Now you form this. Now from this, we want to add there, we want to form a dihalide. Like what I told you, we can form alkynes from Vic dihalides. So what we do, we add there chlorine gas. Oh my god. Chlorine gas in presence of an organic solvent, which is carbon tetrachloride. So this is an organic solvent. So you will form this, and this one occurs at room temperature, so you don't need. So you form this. Now from here, we can convert this to an alkene. And what do you use? You use an alcoholic alkaline. As simple as that. CH3, CH, 2, then OH. That's pretty good. In presence of coal, potassium hydroxide. You remember this reaction? Yes, it is the same. Even the mechanism is the same. With some heat. If you don't heat, then I don't mark. And if you don't put heat here, I'll mark this, and I won't mark this, so marking stops here. So even if everything this side is correct, it will be wrong. Okay? Now from this, then you form this. Now here, this one, from ethane, we can form propane by adding the carbon atom, because that's our interest. And this one occurs in 2 steps. Where the first step, we can add there sodium. Okay? Sodium, sorry for that, in presence of liquid ammonia. Okay? Liquid ammonia. Liquid ammonia. That is the first step. Okay? Now the second step. Now I just wanted to summarize this, but it occurs in 2 steps. And so if it occurs in 2 steps, then you write 1 to indicate the first step, then you write 2 to indicate the second step. Then the second step is you add there your alkyl halide of your interest. If you wanted 5 carbon atoms, then we shall add an alkyl halide with 5 carbon atoms. But we want just 1, so we shall add just a methyl halide. It could be this methyl bromide, or you can add methyl chloride. It is still the same thing. Then you form this. If you don't write 1 here and 2 here, it means this is the same reagent, which is wrong. But writing 1 shows that is the first step, 2 that is the second step. Okay? Now after here, then we use our hydrogen. Somebody wants to be admitted. Our hydrogen in presence of Lindera's catalyst. Okay? Lindera's catalyst. Lindera's cat. Okay? You form this, it will be partial reduction. Now we haven't studied this. We shall add acidified water. Okay? Acidified water. So water in presence of an acid. Okay? This is a plus. But now, with some warming, you do the warming. It doesn't occur at room temperature. There is some warming. But the challenge is, if you just write this, then we follow Markovnikov's rule. We are going to find it down. And the H is going to add itself here, and the OH is going to add itself here. And so we shall cross you. It means that you are lacking some chemistry. Hey, I'll fire you. Remember, I'm the boss. I'll fire you. So for you to form this primary alcohol, then you have to add this, but in presence of Markovnikov's. Then you add there an organic peroxide. ROX. R. And if you do this, trust me, you get all the marks. If we are marking, then we shall give you a mark for this, a mark for this, a mark for this, the same, and the same. And if it is 5, then you get 5. Let me go and admit somebody, okay?